Welcome back to the next session of units and measurement. Friends, in the previous videos we understood the meaning of physical quantity, fundamental physical quantity, derived physical quantity, what is measurement, what is unit, types of units, that is fundamental or base units and derived units, and how many fundamental units, that is 7 fundamental units, and 2 supplementary units, that is radian and steradian, and the measurement of the length. Friends, today we are going to discuss on the next topic, that is measurement of mass. We all know, if I want to measure the mass of my body, simply I will stand on a weighing machine, and that weighing machine will show the weight of my body or mass of my body. But the question is, how exactly we are going to measure the mass of the different bodies? Let's say even it is possible to calculate the mass of the sun. At the same time, it is possible to calculate the mass of even atomic and subatomic particles. How these methods are, how many methods are, how many types of methods are adopted to calculate the mass of these objects? Only that much is fundamental topic or fundamental explanation given to you in this year. So let us start one by one. The first property, the mass is a basic property of matter. Mass is a basic property of a matter. Basic property of a matter. Second thing is, if you take any object or if you take any body, the mass of the body cannot be zero. That is the next point. Mass of a body cannot be zero. Cannot be zero. This is the next point. Suppose if let us say, consider your mass only, the weight of your body. Suppose if I take you to extreme high temperature zones or extreme low temperature zones. Example, say if you go to Delhi in the summer season, the temperature raised to till 50-51 degrees Celsius. And from Hubli, we are the Hubblians, and if I go to, or if we go to Delhi, question is, even though at high temperature, will our body mass changes? No, remain same. That means temperature doesn't matter. Or even if I take you to Kashmir in the spring season, the temperature falls even less than 0 degrees Celsius. In that condition, will our body mass change? No. That means temperature will not affect the body or the mass of the body. That means mass is not depending on the temperature. Suppose if I put the pressure on a people, right? Then if I weigh, then pressure is again not a matter on which a body mass depends. So that means I can say mass is not depending on, independent of. Mass is independent of temperature, pressure, or location. Let us say location means place, etc. Location, etc. Next thing, if I go to the next point, then already in the previous second video we studied the SI unit of mass is kg or kilogram. Mass is measured in what? Kilogram. Mass is measured in kilogram. Next point is, if I want to measure the mass of the commonly used bodies, only our normal balance, what we see in the provision store, what we see in the weighing machines, or what we see in any mall where you can see the digital weighing machine putting 1 rupees, and if you stand on that, they will show the mass. This is called as a common balance. So whatever we use in commonly used object, so the mass of those objects can be determined by using the normal balance. But if we want to measure the mass of the heavenly mass object like any celestial bodies or any celestial object, such type of celestial object of the mass of such objects can be measured using another method called as gravitational method. So that will be the next point. So mass of commonly used bodies can be determined by using balance, by using the balance, way balance or just balance, and mass of planets can be determined by using gravitational method. This is one more point. How we are going to calculate the mass of the sun? How we are going to calculate the mass of the Mars? How we are going to calculate the mass of the Venus, Jupiter, Mercury, etc. Use the gravitational method. Suppose if I want to measure the atomic or subatomic particles, mass of atomic or subatomic particles like nucleus, like electron, like proton, subatomic molecules. The mass of atomic or subatomic molecule or bodies can be determined by using mass spectroscopy. This is a special method. Mass spectroscopy. And mass of a body does not depend on shape, size, and stage of the body. That is one more point. So mass of the body does not depend on shape, size, or stage of the body. These are some important points related to the mass. And if we calculate the range, so till date, the range of mass, till date calculated, range of mass, it is of the order 10 raised to minus 30 kg to 10 raised to plus 55 kg. You may surprise with the value. What is meant by 10 raised to minus 30 kg to 10 raised to minus plus 55 kg? If I take this one, so this is somehow related to the mass of electron. Mass of the electron is of the order 10 raised to minus 30, that is 9.1 into 10 raised to minus 31 kg. Then mass of the 10 raised to plus 55 was here, mass of visible universe. Visual universe means whatever we see till now, that is mass of the visible universe is of the order 10 raised to plus 55. That is not the meaning that there is no values. There are values. 9.1 is there, but we are not considering the 9.1. Only we are taking the power, that is 10 to minus 30. From that lower range, that small range, that atomic level to or subatomic level to this inverse, that is 10 to plus 55. That is still gravitational method. So these are the range of the masses. So with this, we are completing the measurement of the mass. Now, in the next topic, we are going to study measurement of time. Measurement of time. Measurement of time. Friends, we all know time, but can we define time? No. If anybody tries to define time, it's just a foolishness. Why? There is a reason. Because what is the exact definition of time, we cannot. Whoever explains the definition of the time, it is just the describing the time. They are not defining the time, they are describing the time. Time is like this, time is like this. Openly they can only explain, they can say the property of the time, but they cannot define what is the exact meaning of time. But nevertheless, there were certain efforts made by some pioneers of physics. One I can say Galileo Galilei. He made the first attempt to measure the time, for the first time in the world by using some measurements. But later, Albert Einstein said that time is what we measure, what we see in the clock, right? So now, even Stephen Hawking, the one person who just passed away in the last year, he wrote a book, A Brief History of Time. Only we can give the history of time, we can explain the property of time, or we describe the time, but it is not possible to define what is time, right? But with this introduction, let us start some properties of time. What exactly the time means? Time, it is to measure, the time is measured, or it is measured with one vibration called as cesium vibrations. So there is one standard radioactive element called as cesium. It is kept in NPT, National Physical Laboratory in Delhi. There they are measuring the vibrations of the radiations emitted by the cesium, atom, cesium radioactive element, that will emit some radiations. That vibrations will be calculated. Based on that, our IST, that is Indian Standard Time, will be measured. So now one thing, and second thing is there are several types of clocks were developed. So now one by one I will discuss. Before that, let's write some important points which you know already. Time is measured. Time is measured in seconds. In seconds. Second thing is there are many types of clocks were developed. How these are developed? These are developed based on the periodic vibration. Periodic means there is a proper sense of motion, right? Or can say conscious motion. So that is called as periodic vibrations. Based on these periodic vibrations, the time or different types of clocks were developed. So if I name them one by one is electronic types of clocks. I can write here types of clocks. One, electronic oscillator clock. Electronic oscillator clock. Second one, electronic oscillator clock. Next one is electric oscillator. Electric oscillator. Electric oscillator. Then the third one is solar clock, solar clock. The next one is quartz clock, quartz crystal clock. Whatever I wear about this is a quartz crystal. So quartz crystal glass or clock, and the fifth one is atomic clock. Atomic clock. Using this, we have defined some time periods. That is, say one by one. If I say solar day. Solar day means time taken by the Earth to complete one oscillation on its own axis. That is a day, 24 hours. If I go to the solar year, time taken by the Earth to complete one rotation around the Sun. Next one. Then if I take a leap year, as you know that leap year, it is divisible by 4, and it appears only 4 times, once in a 4 year, and in the month, and in that particular month, that is February month, and in that leap year, February month will have 29 days. And along with that one, we have one more smallest, practical, value of time, that is one shake, S-H-A-K-E, shake. One shake is equal to 10⁻⁸ seconds. Only we can explain about this, only this much information is available with respect to the time. More than that is undigestible to you. Less than this is not to your level. So only this much is given to you as in the name of measurement of time. Friends, with this we are completing the measurement of length, measurement of mass, and measurement of time. Thank you.